Determination of charge of an electron by Millikens oil drop method. This is used to determine one of the fundamental constants of nature known as the charge of electron. Let us explore the experimental setup. This apparatus consists of two horizontal circular plates A and B. A and B are circular plates. Its diameter around 20 centimeter. They are separated by the small distance, say 1.5. centimeter. The entire setup is kept in a chamber, a cylindrical chamber. There is an atomizer to pump the oil inside. And there will be a small perforation through which an oil droplet is allowed. There will be a light source to spot the traveling of this oil droplet. And these two plates are connected to the battery with positive charge on the upper side and a negative charge on the lower side. We can also have a simple schematic diagram to understand the concept better. So this is the anode plate A, this is the cathode plate B. There is an orifice here, and let us call it, this is the oil pump, atomizer, from which oils are dropping like this, and we are permitting one drop like this, and we have got the light source here and we have kept a microscope also here. So the plates are enclosed in a chamber of glass walls, and plate A and B are maintained at high potential around 10 kilovolt, that is 10,000 volt, and the electric field acts vertically downward. A small hole is made at the top in the upper plate A, so that it will allow fine droplet of high viscous non-volatile liquid. Like glycerin. It is sprayed through the oil atomizer. They can fall freely downward, and through the top hole that will be falling downward under the influence of gravity. Few oil drops in the chamber can acquire electric charge, that is negative charge, because of the friction with air, and also by passage of X-ray also. We can pass X-ray also in order to charge them between the plates. It goes here. So what is the role of X-ray? To charge the oil droplets. And we can observe the movement of oil, either descending or ascending movement of these oil droplet through a microscope kept perpendicular to the light beam. Now, the oil droplets can move either upward or downward. In fact, we can draw the free body diagram of oil. Oil droplet. So here this is the oil droplet. It moves down under the gravity of Earth. In this way. So this is force due to gravity. Next we have the buoyant force that acts upward, that is indicated by FB. And FV is the viscous force. This is FV. And you have got the oil droplet here. This is without electric field. Now we have the oil droplet moving under the influence of electric field. So this is as usual the force due to electric field, acceleration due to gravity, and this is due to buoyant force, and we have the force due to electric field. So this is with electric field. So this is the oil droplet. The forces acting on the droplet are gravitational force, that is given by mg. Electric force that is given by, what is that? E, right? Buoyant force, that is due to buoyancy. Floating. You know something about the Archimedes buoyancy principle. And D is the viscous force. In fact, the buoyancy force is given by sigma into 4 by 3 pi r cube into g. This is called the buoyancy force, where sigma is the density of air. In fact, that is the upthrust force. That is the upthrust force experienced by the oil droplet due to the displaced air. And the viscous force is given by the Stokes law, 6 pi eta into R into V. M mass of oil droplet E electric field G acceleration due to gravity or radius of oil eta coefficient of viscosity eta coefficient of viscosity eta is equal to coefficient of viscosity. Sigma is the density of air. V is called terminal velocity of oil droplet. That is the constant velocity achieved by the oil droplet. Rho is the density of oil. In fact, this Fg or mg that can be given as rho into 4 by 3 pi r cube into g. I'll tell you how to convert this. I think I have given all the parameters involved in this set of derivations. Now let us determine the radius of oil droplet. determination of radius of oil droplet. When the electric field is switched off, the oil droplet accelerate downward. So the oil will be moving downward. But because of presence of air, the oil is dragged upward also. So the oil drop attains its terminal velocity. That is moving with constant velocity. That is considered to be terminal velocity. So this is measured by noting down the time taken by the oil droplet to fall through predetermined distance. A predetermined distance. In the absence of electric field, the force due to acceleration due to gravity is controlled by the two forces, buoyant force and viscous force. Okay. Fg is mg, is it not? Fg is equal to mg. We know rho, the density of oil, is nothing but the ratio between mass of oil divided by volume of oil droplet here. V, volume of spherical oil droplet. Being a sphere, we know V is equal to 4 by 3 pi r cube, where r is the radius of oil drop. Okay, so we can replace this volume by 4 by 3 pi r cube. Okay, therefore m is equal to rho into V, is it not? Because rho is equal to m by V, m is equal to rho into V, right? So when V is replaced, we can introduce this 4 by 3 pi r cube. Okay, this is m. Now mg, which is nothing but fg. Now it is rho into 4 by 3 pi r cube into g. Is it clear now? So what is this Fg? That is due to the force due to gravitation. That is gravitational force experienced by the descending oil droplet. Now when the oil is moving downward, it has to replace the equal volume of what? Oil droplet, that is air here. Is it not? It has to replace like this. So this is the volume of oil drop, and this is the equal volume of spherical, or I mean air, you can say air. Okay, now let us consider the density of air as sigma. Density of air as sigma. Now Fb buoyant force is nothing but m dash g. Okay, because of the buoyant force, the mass may vary here, so we had to put m dash. Now we know sigma is equal to mass of that air, m dash, divided by volume, and the volume is nothing but 4 by 3 pi r cube, the same radius of air, that's all. So we can make use of this equation. Therefore instead of m dash we can put that is m dash. Okay, and here instead of v we can put this one 4 by rho is equal to what here? Not rho, sigma is equal to m dash, and instead of m dash we can put sigma into v, is it not? So let us put sigma into v. Therefore sigma into what is v? 4 by 3 pi r cube, and this is g, so you can introduce g. Is it clear? So this is the buoyant force, right? Take down. Now once the oil droplet attains the terminal velocity, the net downward force acting on the oil droplet is equal to the viscous force acting opposite direction, right? As we have mentioned here. Okay, so Fv is the viscous force. By Stokes' law, viscous force is given by 6 pi eta r into terminal velocity. Now from the free body diagram we can find here Fg is equal to the downward force. Fg is equal to the sum of two upward forces. Are you able to follow this? So what are those upward forces? B and V. Therefore Fg is equal to Fp plus Fv. Okay. Now we can suitably substitute these equations because we already know what is Fg and what Fb and Fv are. So what is Fg? Sigma into 4 by 3 pi r cube into g is equal to, what is Fb? Buoyant force, which is nothing but the force due to buoyancy, that is due to the air displaced. So sigma into, this is rho, this is sigma into 4 by 3 pi r cube into g, correct, plus the viscous force 6 pi eta into r into v. This v is the terminal velocity. We can bring this to LHS. Therefore sigma into 4 by 3 pi r cube into g minus sigma into 4 by 3 pi r cube into g is equal to 6 pi eta r v. So here this quantity is common, being GCD we can take outside the bracket, is it not? Therefore 4 by 3 pi r cube into g of rho minus sigma, correct, that is equal to 6 pi eta or terminal velocity v. Okay. Now we can divide by 2 so that you can reduce this, is it not? So multiply by 1 by 2, so 2 2s are 4, so it becomes 2 by 3 pi r cube into g into rho minus sigma is equal to, this becomes 3 pi eta r into v. Okay. Now from this we can calculate, and this becomes r cube. We can bring everything to this side, and r cube becomes r squared because of these two r. Okay, so r squared is equal to 3 pi eta into v divided by, we can bring everything here, and this becomes 2 by 1 divided by 2 by 3 means 3 by 2. Okay, and 1 by pi g. I cancel the r cube as r squared. Okay, right? Now we have pi can be cancelled, therefore 9 by 2 into eta, and we have this rho minus sigma also, right? So eta V divided by rho minus sigma into G. So R square is equal to this much, means R is equal to whole power 1 by 2 or the square root. So this is the radius of the oil droplet. Now eta is the viscosity coefficient, that is a constant. Terminal velocity is the experimental value, that is also a constant, and rho is the what? The density of oil. Sigma is the density of air. Acceleration due to is gravity is g. By calculating all these values, we can easily find out the radius of oil. Otherwise, it would be very difficult by using any instruments, any micrometer, or you cannot use any screw gauge to measure this oil droplet. So this is the indirect way of determining the radius of the spherical oil droplet. Is it clear? So this is the first phase of the equation. Now we will move to the second phase, that is determination of electric charge. B. Determination of electric charge. So here, when we apply the electric charge, now look at this diagram. See, the descending oil can be countered by the electric charge here, as in the case of viscous force, when it is without electric field. With electric field means there are two forces influencing on the descending oil droplet. One is buoyant force, the second one is electric force only. Whereas in the case of the descending of oil droplet without E is controlled by two factors. One is buoyant force, another is viscous force. So here we are replacing this with this electric force. Okay, right. Now this Fe is net force of Fg and Fb. Otherwise you can call it Fe plus Fb is equal to Fg, correct? What is this Fe, which is nothing but QE plus, we know the value of Fb, 4 by 3 pi r cube into rho into, sigma into G, that is due to air, and here 4 by 3 pi r cube, and instead of sigma you have to consider rho being the density of oil into G. This is the gravitational force. Right? Now this QE is equal to, we can bring this here, otherwise you can bring it here. So QE is equal to 4 by 3 pi r cube right? 4 by 3 pi r cube into rho minus sigma into g, and from this we can calculate q. So 4 by 3 pi r cube divided by e into rho minus sigma into g, correct? Okay, now we have already derived the equation for the radius of oil, that is r. Okay, we can substitute this equation here. Therefore q is equal to 4 by 3 pi by e into rho minus sigma into g. Now we can replace this r cube by this one. So r cube means 3 by 2 in this case, because we know x power 1 by 2 whole cube means x power 3 by 2, correct? That is a power m whole power n is equal to a power mn. In this way we can have 9 by 2 into eta terminal velocity divided by rho minus sigma into g whole power, instead of 1 by 2 we can have 3 by 2. Got it? Okay. Now I can bring this cube inside. Therefore 4 by 3 pi by e into rho minus sigma into g, and I can take 9 cube means 27. 9 cube means what? 9 into 9 into 9, is it not? Okay, 9 into 9 into 9, 9 cube divided by 2 into 2 into 2, 8, is it not? Into eta cube divided by rho minus sigma of g, okay, whole cube, right, whole cube, and then what we have, power 1 by 2. So I have taken this in order to strike out this. Okay, now we can further simplify this as q is equal to 18 pi divided by e, and this is squared means the square can be cancelled. We can take outside this, okay, and cancel. Okay, so you can once again put, we can bring it inside so that we can cancel it, and I have taken this 9 also, cancel this and put 18, and 2, this is also cancelled, so I can put 2 here, and eta cube is already there, then v cube is there, and you have divided by 2 into, this can be brought here, therefore rho minus sigma and G, and once again you can put cleverly 1 by 2. Okay, so this is the way you can rearrange. So the final equation is Q is equal to 18 pi divided by E into n cube, eta cube, V cube. What is V cube? Terminal velocity. So all these values are known. So using this, he was able to calculate, that is Q. And Q is nothing but integral multiples of electronic charges. Okay. So by taking the number of moles, we can calculate the charge also. So when you divide by number of moles, you will get the charge of electron. So the charge of electron is found to be minus 1.6 into 10 power minus 19 coulomb by Millikan. So this was the basic value he was able to obtain. And based on this specific charge value and Milliken's oil drop value, we were able to calculate the mass of electron. How? Now we have the mass of electron. What is the value of E by M? Now let us calculate the mass of electron also. So you have Millikens experiment value E divided by E by M. So what is this? This is Millikens value. This is J.J. Thomson value. Okay. Now tell me the Millikens value. 1.6, of course minus, so minus, we take absolute value, so 1.6 into 10 power minus 19 coulomb divided by, what is the E by M value? 1 point into 10 power minus 10 power 11 coulomb per kg. So 1.6 divided by 1.7. .941 into 10 power minus 19, this becomes 10 power minus 11, is it not? So coulomb can be cancelled, you have got kg, right? So 0.941 into 10 power minus 30 kg. You can make it as a scientific notation, so 9.4 into 10 power minus 31 kg. So this was the mass of electron determined. From Milliken's value and J.J. Thomson value. Okay.